So now we are on Unit 3, so we're getting into more of the meat of geometry here, and we're going to study triangles again, but we're going to be proving that triangles are congruent, or that parts of triangles are congruent. So let's figure out some definitions first before we continue with those proofs by the end of the lesson. We'll kind of introduce them. So 4.1 is about congruent figures. So it says whenever two figures have the same size and shape, they are called congruent. So that's the definition. If two figures are congruent, then they have the same size and shape. We've already learned about congruent angles and segments. Now we'll learn about specifically congruent triangles. So it says two triangles are congruent if and only if their vertices can be matched up so that their corresponding sides and angles are congruent. So if you can match up vertices, so look at these triangles down here. If we can match up vertices, then their corresponding angles have to be congruent and their corresponding sides have to be congruent. And if that's true, that means those two triangles themselves are congruent to each other. So if you cut one triangle out, put it on top of the other, they should match up perfectly. So what's going to be super duper important in this unit is the order in which we write our congruency statements, the order of those letters. So this right here is called a congruency statement. Okay, so that's your mathematical statement that says, if you were to write it in sentence form, the triangle ABC is congruent to triangle DFE. So based on this one statement, I can then identify which angles are congruent to which angles and which sides are congruent to which sides. So in other words, which angles correspond to which other angles from triangle to triangle, and which sides are congruent to which other sides. So how do we do that? Well, you go in order. Letter A is the first letter here, letter D is the first letter here. So that means angle A is congruent to angle D. And then you go with the second letter. So angle B must be congruent to angle F, according to the order of those letters. So they're lining up corresponding angles here. So angle B is congruent to angle F. And then finally, we have angle C is congruent to angle E. So don't assume that I have triangle ABC, I have triangle DEF, that they are in that same order alphabetically all the time, because that's not the case, which is why I purposefully put the F lining up with the B and the E lining up with the C. And don't assume they're going to look identical and side by side. We might rotate this, put it upside down, put it opening on its right or left, so long ways, short ways, so it's going to look different. So you have to line up the proper letter to identify which angle is congruent to which other angle in the two triangles. Now for your sides, we're going to look at the combination of letters. So these first two letters here, A, B, are going to be congruent to the first two letters here, which are D, F. So that means A side AB is congruent to side DF. And then you're going to do your second two letters, BC, are going to be congruent to your second two letters, EF. So that means side BC is congruent to side FE. And then finally, side AC, right, first and last letter, must be congruent to side DE. So again, how am I getting this? I'm getting this by the order of the letters in the statement. Don't necessarily go by the way it looks or go by alphabetical. It's the order of the letters in the congruency statement. Okay, so now you might want to pause. If you didn't grab a compass and a straight edge, you might want to pause and go ahead and get your compass and straight edge and then come back, because we're going to do some constructions. Okay, so the first thing we're going to do, this is a scalene triangle right here, DOG. And I have segment AT, and I want to construct a triangle such that DOG is congruent to CAT. So OG must be congruent to AT. So this length here is the same as this length here. Okay, so now I have to figure out where letter D is going to go. Or sorry, letter D is right here. I have to figure out where letter C is going to go. So what do? Well, hopefully you're kind of instinctively doing this. You're going to take your compass, and you're going to open it up to measure this length right here. Right, so I measured that length, so now I have to, so if I did a little mark right there, you can see it's the same. So I'm going to come over here, and I'm going to measure that length. So there I have it. Now, I have to have a point of intersection, so I'm going to come to letter O and measure the length to D. So there I can see that's about the same. So it's the intersection. I measured from DG to D and O to D. So now I'm going to go from T to C and from A to C. So this is letter C right here. So then you can take your straight edge and you can line it up. So here I'm going to take my straight edge, line it up. So that is one location for letter C. Now, is that the only location? So I can see DG is congruent to CT, CA is congruent to DO. So far it looks okay. If we cut this triangle out CAT and put it on top of DOG, it should match. But was that the only spot I could have done? I don't think so. Right, so where else could I have gone? Well, if I continued this circle, what about over here on this side of A? Right, what about over here, if I went back and I measured the distance from C to A, which is the same as D to G over here, and I scoop my compass down this way, well, there's another option right here. This is another option for C. Right, so I can connect here, here, and I can connect here, here. So that's another option, CAT. C, I still have this distance, CT, which is the same as DG, I still have this distance, DO, which is congruent to CA. So I actually had two options there. Just like I could reflect D over here and make a whole nother DOG if I wanted to. So these four triangles would all be congruent to each other. But specifically, if I want to make DOG congruent to CAT, I could have put either the C up here and made this triangle CAT, or the C down here and made this triangle CAT. Okay, now not only are polygons congruent sometimes, or sorry, not only are triangles congruent, we also can have polygons congruent. So can polygons be congruent? Of course they can. It's still the same definition. Their vertices must be matched up so that their corresponding parts, which means angles and sides, so parts or angles and sides are congruent to each other. So two polygons are congruent if and only if their vertices are matched up so that their corresponding parts are congruent to each other. So down here I have a pentagon, B-R-A-K-E. And I want to make a pentagon C-H-O-K-E so we can make it congruent to this. Well, one of the things you need to notice is that C-H-O-K-E shares the K and the E. So it's has to be connected. You can't have a whole different segment with the same label. That means it shares the segment. They must share that common side right there. So it says, notice both of these polygons have the letters K and E in them. This means they must share a common side. So what am I going to do? I'm going to take my compass. I'm going to open here to letter E. And I'm going to measure from B to E. And I'm going to scoop around and I'm going to try to make that mark out here. But remember, you can't do a point. We don't know where it is on this point, so we have to have another point of intersection. So if I go down here to letter K, and I measure that distance from K to B, that's my only other option. All right, so that's my other length. So I'm going to scoop around here, and I'm going to measure that distance so I can see from E to this point of intersection. That point of intersection is right here, so if I connect, there's one point of intersection. So C is going to be right here. Now how do I do letter H? Well, again, I have to do these 2 points of intersection. So I go back to letter E, and I put my compass over here, and I open to measure the distance from E to R. And then I scoop around, and I make that little mark out here in space, and then I move my compass down to K. I go back, open it to letter R. I scoop around, and then that point of intersection is going to be where letter H is. And you have to do it one more time. So now I put my compass point back here on K, move it down, open it to letter A, scoop around, oops, and then I can put it up here on E, move my compass, open it up, scoop around, and so that is my letter O. So there is C-H-O-K-E, B-R-A-K-E, so we know that B-R-A-K-E is congruent to C-H-O-K-E. So what does that mean? Well, you should think of things that means that angle B is congruent to angle C, angle R is congruent to angle H, angle A is congruent to angle O, angle EKA is congruent to angle EKO. Notice I couldn't just use the letter K by itself because there are two angles for K. So maybe we could just put numbers. Angle 1 is congruent to angle 2, which is these two right here, or angle 3 is congruent to angle 4. Right? And then we can do segment statements. We can say BR is congruent. Segment BR is congruent to segment CH. Segment RA is congruent to segment HO. And then we can keep going around, all the way around. Right? OKKO, same thing. And then EK is congruent to itself, or KE, same. EKKE, BRRB, CHHC, same. Those are segments that are actually congruent to each other. Okay, I'm going to pause here. I'm going to start a new video, so you can go ahead and look for the new video, the second video.